Absolutely love the problems here in review set 3. Just algebra enough, a little bit of proof, but not a super hard proof. Like this first one, think of this g and its complement. If you added up all the edges of g and the complement, what kind of graph do you have? Complete, right? So if you took e for the regular graph plus the complement edges, you should get the number of vertices. Choose what? 2, right? V choose 2. The complete graph. Yep, handshake problem. So we know E is 17, we know E prime is 11. We just have to go V times V minus 1 over 2. Anybody having problems with where that formula came from? Do you want me to show that? Sure. So you have V choose 2. That's going to be V factorial over V minus 2 factorial times 2 factorial in the denominator. So this is V times V minus 1 times V minus 2 times V minus 3, V minus 4, 2 times V minus 2 factorial. See how those cancel and give you that? I love that kind of math. All right, so then we're not done here. 28 times 2 is equal to V squared minus V. Put everything on the same side, you get V squared minus V minus 56. And this factors into what? By the way, 56 is the most common missed multiplication of all third graders. 56, oh yeah. 7 times 8, yeah. And by the way, we want a minus here, so this will be a minus 8 plus. By the way, if you're ever teaching little kids how to do multiplication tables, don't make them memorize 7 times 8. Just ask them what 7 times 2 is. 7 times 2 is? Double it. Double it. There it is, 7 times 8. That just happened. That's how I taught my kids, and they were teaching all the other kids how to do 7 times 8. But anyway, so V plus 7 times V minus 8. So what will make this true? V equal to negative 7 or 8? Well, which one doesn't make any sense? Negative 7, so 8, as Alex already found. Correct. Nice job. Well, let's talk about bipartite number 2 here. K of m comma n. That's if you have m across the top, n across the bottom. And what can you tell me, what does m plus n mean? That's the number of vertices. What, for a bipartite graph, what's m times n? The edges, yep. So let's get rid of n algebraically, and you get n is equal to v minus m, and n is equal to e divided by m. You okay with that? Set n equal to n, and you'll get v minus m equal e over m, and my edges will be m times v minus m. Okay? That isn't too bad, is it? Algebra from those? Did I do anything crazy? Well, I'm going to do something crazy here. Now, if I multiply these through, I'm going to get mv minus m squared equal to e, and put everything on one side, I get m squared minus mv plus e. This looks like, to me, looks like a quadratic. And we'll call this A, this B, and this C. Did I lose anybody? That's further math, not honors pre-calc. So now what we're going to do is we're going to find the max value. So the max value is probably going to be what identifying element of the parabola? The top, yes, called the vertex. And that vertex can be gotten from this famous formula, minus b plus or minus square root of b squared minus 4ac all over 2a. And where that vertex comes from is that if this part here is minimized to 0, what's left is the maximum value. And the max, x max, happens where? If this goes to 0, what's left? Negative b over 2a. That's the x value of the max. Write that down. And now we're going to find... Huh? Why does it go to 0? It has to do with if you do hit an x-axis, this is the point where you get the double roots. And this is kind of the double root at a certain y value, or the max. So you want to minimize this so it disappears, and then this is what's left for your max. Okay, so now, so for the max, did we just do v max? Yeah, the max m value, I'm going to go minus b, so this is my b, minus a negative b over 2 times a, which is 1. So this is my value of m that's going to get me the max number of edges. It's not, that's old honors pre-calc stuff. It seems hard, but it's not. So now let's find out what the edges are. The edges are going to be m times v minus m squared. This is my m. So we're going to do v over 2 times v minus v over 2 squared. And we're going to get my edges. This is going to be, the edges are going to be less than or equal to this. So what's v squared over 2 minus v squared over 4? That's going to be v squared over 4. That's what you're trying to prove for that one. That was a little tough. Yeah. So, classify the following graphs. Are you okay with these from looking at the answers? Anybody having trouble with any of these? Just please, when you draw these, just count the vertices, the edges at each vertices. So this one has 1, 2, 3, 4, 4, 4, 4, and 4. So what does that mean? If they're all even, it's Hamiltonian and it's going to be Eulerian. So this is going to be both Eulerian and Hamiltonian. Remember when we had 2 odds, then it's going to be semi, right? K2, 3, 1, 2, 1, 2, 3. Okay, and this has 3, 3, 2, 2, and 2. So what's that going to be? Semi-Eulerian. And semi-Hamiltonian because of the 2 odds. This is 3, 3, 3, 3, 3, 3, 3, 3. All those are 3s. So that's going to be what? Neither. Anything over 2 odds, it's going to be neither for Eulerian. But how about Hamiltonian? This one's kind of cool. For Hamiltonian, you can go around here. That is Hamiltonian. Okay? And then these are all 4. These are all 4, so that's going to be what? Eulerian. Oh, wait, no, I'm doing Hamiltonian here. It's going to go around here. Got it. So that's Hamiltonian, isn't it? And Eulerian. So Eulerian for sure, and Hamiltonian easily. Okay, let's do number 4. This one's probably the last one we'll get to. It's an easy one. A simple graph here, V vertices, E edges, and the same number of edges in the complement. So E plus E is equal to V choose 2. I bet you could do this one now. 2E is equal to V times V minus 1 over 2. And so this is going to be 4E equals, when we do, oh yeah, V times V minus 1. And if we're dividing by 4, aren't you looking for E is equal to V times V minus 1 over 4? Isn't that what we're proving? Or no, that's what we're going to find. That's the relationship. If the complement equals edges equal the number of edges in the graph, it's going to be V times V minus 1 over 4. And then the last one, sewage network, got to end up with a sewer problem. We're going to have, if there are entrances at each of the nodes, where should the inspection start and finish so it requires walking a minimum distance? So if I started with B, okay, you want to walk the whole thing, you just go like this, and you've walked all of those, right? And then you have to end up over here. Because this is a 3 and this is a 3. All of these are 2s, 4s, and 2s. So when you do this cycle, it's going to go here, 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 and then end at C. State an inspection plan that covers each one once. Okay, I think we did that. And you could start at B and end at C, or start at C and end at B. I'll let you look at the answer for that. And then the last one, suppose inspector must start and finish his inspection at A. So you're starting here. And which tunnels will be covered twice for him? So which ones are you going to cover twice? B to C. So what I would do is I would just add all those up. 110 plus 126 plus 146 plus 74 plus 95 plus 147 plus 133. And then using your new math skills, just add what? 146 a second time, and that should give you 977. Test tomorrow.